to look at the formula for the sum of finite geometric series. So how can you find the sum of a finite geometric series? Well, let's start with just summing a finite geometric series using geometric sequences. So A2, A3, these are just the term values that we get when we sum all our term values together. So this is a sum of all the term values together. Well, I know from previous examples that A2 is basically A1 Rn minus 1, which is to the first power. A3 is going to be A1 R3 minus 1, which is the second power. 4 is going to be A1 R to the third power. And we will end with AN R to the n minus 1. Sorry, not AN, A1. So S of n represents my geometric sequence, or series. All right, so something that each of these have in common is my R, except the first one. The first one does not have an R. So what if I came through and let's just say that I want all these to have my common ratio. So I'm going to multiply R to the whole thing. Again, this is a concept. This is kind of just like a proof of the equation. So I'm going to multiply R to everything. So I have R times the sum equals A1R, A plus A1R squared plus A1R 4 plus A1R 5, and so on and so forth, R to the n. All right, so the next thing I'm going to do is I'm going to subtract the second equation from my original equation. So I'm going to take S, the right color so you guys can see it, Sn minus R of Sn. And what I get here is essentially A1 minus R of A1. So this guy right here will cancel out this guy right here. This one right here will cancel out that one. This one, I forgot a 3 here. This is a 3 and 4. We'll cancel out that one, and so on and so forth. And what we are left with is A1 minus the last term, A1R to the n. Okay, in both of these we have a common factor. So Sn is common to this side, that's 1 minus R. This one has A1, 1 minus R to the n. And again, this is just proving this formula. Now looking at this, we have Sn equals A1, 1 minus R to the n divided by 1 minus R. For R cannot equal 1, because if R is equal to 1, we have a 0 in the denominator. So notice that multiplying each side by R gives you the second equation with many of the same terms of the original equation. How does this help us eliminate? Well, this helps us eliminate by essentially giving us each one of these terms from equation 1 into equation 2, so we're just left with the first and last term of each equation. Now, where does this come into play? Well, let's look at this. We're going to look at how we actually show that we're looking at the sum between two values. So we're going to write the equation, the sum, S of n, is equal to the sum, and this right here is a sigma. So can you see that? Yeah. Greek letter, it's a capital, and this is denoting that we're going to do the sum of. Then we start our beginning term value. Our beginning term value starts at 1. Our last term value is at 7. This is a finite. We're going from 1 to 7. Okay, we have 3. 3 is going to be our A1 value. 2/3 and minus 1. So this is A1. This right here is our rate. So what is the sum? So what we're looking at here is we're just essentially going to rewrite it, because I don't know why I just decided to rewrite it. N equals 1 to 7 of 3 2/3 and minus 1. This is just going to equal A1, which is 3, plus 3 2/3 A2. This is to the 1 plus 3, A3. 3 minus 1 is 2, plus 3, A4. 4 minus 1 is 3, plus A5. 5 minus 1 is 4, plus A6, plus A7. I run out of space. That's 6. And I could write it out all like this, or I can take that last formula, so S7 is equal to 3 times 1 minus 2/3 to the 7th power divided by 1 minus 2/3. And here we get 2059 divided by 243. So the sum of this, the sum of n equals 1 to 7 of 3 times 2/3 and minus 1 is equal to 2059 divided by 243. Right, and then we could always check this by adding all these up together and seeing that we do actually have the same sums. All right, guys, a couple of new things in here for you to look at and do, and a couple of new Greek letters. Remember, this is summations. Your calculator does have the summations. It is, I believe, under the math key. So in a TI-84, you're going to go under math, and then you're going to go to 0, sum, and it looks like this with the little parentheses. So your calculator does have the summation key, but if you needed to ever do it by hand, because you know what 1 minus 1/3 to the 7th is, but if you ever need to do it by hand, you do have the nice formula. Alright guys, so this is the end of this video. I will catch you in the next video. Again, if you have any questions or comments, please feel free to ask. And I always felt it like saying, remember to smash that like button and subscribe for more math videos. Alright guys, so we'll see you next time.